Good afternoon, everyone. So today, I would like to introduce our work for the photo reforming of the plastic waste, and we use the UV and visible light, so can degrade, and also we use nanocomposite, the photocatalyst. Our group includes Dr. Pei Xu and professors of environmental engineering, and also PhD student Thiloka. So for the innovations, first we talk about our system. Our system is a very simple, and also we just put the photocatalyst inside the solution, the alkaline solutions, and also so that is can save energy. And also another innovations is we prepared the high performance and innovative the item and nanocomposite catalyst. So this kind of catalyst can use both UV light and visible light. For the background, I can introduce for the photocatalyst. Photocatalyst, when it's irradiated by the sunlight, so the electron and the whole pair is produced, then cause a series of chemical reactions and can degrade the plastic and produce hydrogen. So therefore, this method is very easy, but in general, we know hydrogen is an excellent green energy, but it's we know people just use the steam method to produce. So they use the fossil fuel, and also they use high temperatures and high pressure, so that make it very costly. But for our method, we avoid this kind of shortcome. Then also almost 4 billion tons plastic is produced. So then only 40% is recycled. Then 60% pollutes the environment and cause a high health risk. So that is a big problem. Then for our method, we use sunlight and we use photocatalyst. We can degrade the plastic to produce hydrogen. So one stone, 2 birds. That is a good way to solve the problem. Then you know, our system is low cost and also easy to operate, and also it can work under the ambient condition. Don't need the high pressure. Don't need the high pressure. So therefore, it's much easy to control. Then also it can produce hydrogen. Then we can use hydrogens for the hydrogen car, hydrogen bus, and also can produce electricity directly, use a fuel cell. So that we can, for the green energy purpose, also for the byproduct. After the degradations of plastic and be reused to produce the plastic. So talked about a very important topic is cost. Because we use the sunlight, we don't use actual energies. So therefore you can see our cost is very low. 1 kilogram hydrogen, the cost is $1.47. So it's even lower than the steam methane method. Because for our method, we don't have the carbon footprint. Carbon footprint is negative. And also we don't need to do the CO2 capture. So that can decrease the cost. For another, here, you can see we optimized the catalyst and also the pH of the system, and also we optimized the plastic pretreatment method. Then we use different plastic types. And you can see the last column. The last column is the optimized condition. Almost for the, we get the almost 8 times the 8 times the revenue higher. It's use direct deposition method, and another one we use the dark deposition method. So when we use the dark deposition method, we can get the atom nanocomposite, the catalyst. So this kind of catalyst is just like we have titanium dioxide particles. Then we use this dark deposit method. We can deposit palladium, the single atom, on this surface. So therefore, we make this kind of atom nanocomposite the photocatalyst. So this catalyst can decrease the almost 10 times of the cost of the catalyst, and also improve the efficiency. Also, the catalyst can be reused and regenerated. So like this one you can see, we can use the calcination method and just use 500 degrees C. Then for 3 hours. After this kind of regeneration, we get the significant improve of the hydrogen yield. So almost 3 times higher than the before. So therefore, this means for our catalyst, it can be reuse and also can use for a long time. We pay attention for this the byproducts because after those kind of degradations of plastic reactions, and we think about the waste. But for our degradations, after this degradation, we can get the byproducts. For byproducts, you can see we have byproducts, but this kind of byproducts can be used for the hydrogen production again. And also, if we don't want to use that once, we can use the byproduct to reproduce the new plastic. So that once after, that means after reactions, no waste, zero waste. Then we already did the first one. You can see we do the first task, and also we do the second and the third. We optimize the hydrogen production and also submit the patent application. Then we will scale up the system, and also we will do the pilot experiment. So here for the continue to optimize our system. Maybe we will change the different catalysts, and also do the ask for the funding for commercializations, and also for the pilot demonstration. So thank you for your attention. Any questions?
Thank you so much for the presentation. I have a very naive question out of my curiosity. IARC, the International Agency for Research on Cancer, have identified titanium dioxide as one of the class 2B carcinogen. And there will be certain waste products when you're using such a catalyst. And what do you envision in terms of kind of containing it? It's like kind of having the waste products over there, which are like kind of creating more burden on Earth. And then we have a certain component here being used, which is already identified as a carcinogen. So any thoughts or any how the technology can kind of be like avoid usage of these kind of catalysts? I know the cost is one aspect of it, but the sheer usage of that element, that compound, titanium dioxide, is something that I want to understand from your vantage point.
For the titanium dioxide, because it's a commercial product, so it's very cheap, and also it's very effective. So therefore, we use the titanium dioxide to do the modification, because if you use just a single item, the platinum, so it can save a lot of materials. This is the one, I think it's easy to do the commercial work. But also in the future, maybe we also develop also deposit the single item. improve and also deteriorate.
Cheap, effective, and toxic.
Oh, yeah.
That's what I said. It's a carcinogen.
Yeah.
Okay.
But for titanium dioxide, almost no, no toxic. Yeah.
Thank you for the presentation there. I think as we talk about the hydrogen market as a clean energy resource, there's definitely a lot of growth in many companies wanting to produce hydrogen, but there's not a lot of enthusiasm to buy it. And, from different agencies and reports, it's estimated that maybe only 10% of those who are producing hydrogen have any buyers. And so I'm kind of curious if the team there has explored, who the ultimate buyer is and how that thought kind of goes aligned in the commercialization of the product that you have and that you're building.
For the commercial buyer, maybe like you buy like a fuel cell car, and maybe the company, some companies they need the hydrogen, but now we need to grow up and to do the big size the experiment production. I think for hydrogen, all fuel cells it's a hydrogen time.
So first, to answer the question about the carcinogenicity, project, the catalyst will be 100% recycled, regenerated. So we will not release it back into the environment. I think the beauty of this project is we have the zero waste for discharge.
Well, I understand, and thank you so much for the explanation. But the fact remains, people are running away from any product that has phthalates. And if you really look at the industry is kind of changing itself, most of the people are actually getting more and more aware in terms of the long-term impact to their even immunity and overall genetic makeup and structure as a result of these what we were calling as simple monomers. So, but I appreciate you understand where I'm coming from.
Absolutely.
Thank you.
Yes. Thank you for the comment. And also regarding the end users of the hydrogen, actually, like Huiyao mentioned, they can be used for electric cars. And another very important potential use is to blending with the natural gas. Because natural gas is used for electricity generation, and then we can blend the hydrogen generated up to 20% of the nitrogen gas. That's how everybody worries about the storage of the hydrogen, and actually if we can co-locate with the natural gas plant, and then it can be transferred easily.
I love the closed loop nature of this business. Concern I have is with the plastic inputs to fuel the process. There are many, many different kinds of plastics and plastic formulations. Are you going to be constrained in the different types of plastics you can use, and then necessarily the cost will go up and it'll eventually not be quite as compelling from a unit cost? That you can actually use for your process.
Plastic, almost all types of plastic can be like degraded by this method, but maybe for so we just want to use our catalyst, and also we can implement one method is almost hydrolyze the plastic and make the plastic easy to be degrade and almost can dissolve inside the solution.
Yeah,
This
I would
is
just
the easy way.
I would encourage you to get a clear point of view on the costs of the pretreatments and just how constrained you would ultimately be given the process or costs that would go into doing that. I've been involved in some businesses where plastics is part of the supply chain inputs, and it's quite challenging just given the different types of plastics out there.
Actually, we tested 5 types of the plastics, and our initial step is to focus on the low-grade plastics, because for high-grade plastics, they're recycled. And then for low-grade plastic, like PET, PE, and those are available, so they are landfilled. So for those types of low-grade plastics, and this method is highly effective. But as Huiyao mentioned, if we target those high-grade plastic, and then the pretreatment would be very important. And Huiyao did not go to the details because we did a lot of optimization of the pretreatment.
Time for one more? Okay, just a comment then. Thank you for the excellent presentation and Q&A. I would think your early customers for this would be the waste management companies. And so obviously getting in touch with them and getting their feedback and exploring, how to use your degraded plastic as a feedstock, how to work that into the supply chain is going to be a challenge, and especially using a variety of low-grade plastics. So those guys can help, I think. Thank you.
Thank you so much for the comments. And also, Huiyao and I are around. We also have a poster in the next room. Please feel free to talk to us if you have more questions. Thank you.